So guys, can you hear me? First and most important question, because if something is not working with the technique, nice and clear, perfect. Okay, yeah, so today I'm going to show some DLL sideloading related stuff. It's more or less about how to create your own DLL for sideloading. It's more a short overview on how sideloading works, and I'm also going to show you some way to figure out which potential applications are vulnerable to DLL sideloading. So yeah, in the very end, it's or this technique is got more and more popular in the recent weeks or in the recent months, because it's a good way to execute a payload behind some legitimately and signed and trusted executable. So for example, in this case we have the OneDrive.exe from Microsoft here. It's the one that usually everyone has on its or in its app data directory if you're using any Windows system. It's signed by Microsoft. Oh, seems like this is not valid anymore, but I don't care. I think if I'm using a new one, I should maybe I'm finding a new one in this app data directory. But this is not valid anymore. But typically this also works with the newest version, which is still signed and still valid. Yeah, and a good thing about this is that if you have any kind of EDR or AV solution which is, for example, ignoring to scan or to check legitimately signed executables, then it's an easy way to bypass those solutions. So in this case, OneDrive.exe is known vulnerable for DLL sideloading with, for example, the version.dll. So if you drop any your own version DLL in the same directory, this will get loaded and executed by OneDrive.exe. So just to demonstrate this, in this case it's a version DLL which I generated and which is manipulated in terms of it's just popping up a calculator. So the code which is embedded in this DLL is executed, calculator was opened, and afterwards OneDrive was still opened. So OneDrive basically executed the payload in this DLL, and this is a nice thing because it bypasses many vendors at this time still. But one thing to mention, and one thing which is important, more and more vendors start to also flag and detect all the known sideloading techniques. So for example, this OneDrive.exe is known, the OneDrive updater.exe is also known, that Teams.exe is vulnerable to sideloading is also known, and they started to detect, especially for all those signed executables which are known and vulnerable and which were published somewhere. So it's not the best way to actually use a known executable, but you should always search for your own DLL sideloading vulnerable applications, because then the chances of not getting caught are much better. Yeah, how does this basically work? Or first of all, how could we, for example, check for DLL sideloading vulnerabilities? So there's one specific tool which I personally like and used, which can scan for DLL sideloading, which is Siofra. You can find this one on GitHub, and I also put one link on Twitter some time ago, in which I just posted that if you search for any DLL sideloading binaries which are not known yet in terms of not published in any blog post or stuff like this, you could, for example, just scan your whole app data directory or the program files directory to search for executables. do that with Siofra, for example. For 64-bit applications you need to use Siofra 64, and for 32-bit applications you need to use Siofra 32. And you can use this tool with these parameters to scan for potential vulnerable applications, so with mode, file scan, enum dependency, DLL hijack, and then the file which you want to check. Yeah, you can do this for a bunch of applications, or you can do this for single ones, whatever you like, however you like. So in this case, oh, that's the wrong screenshot. In this case I'm going to do exactly this. So I'm going to check one application for DLL sideloading, namely on the one hand side it was OneDrive. First of all, before I'm doing that, I'm going to remove the DLL, because if a DLL is in the same directory and if it's named like a DLL which yeah, okay, so this is good. So this is basically the output from Siofra. If you have any questions in between, just feel free to ask in the chat or something, whatever like this. So it's checking which DLLs are typically loaded by OneDrive.exe. And this is, for example, kernel 32 DLL, it's user 32 DLL, it's some other DLLs which are loaded recursively after user 32 DLL is loaded. Then it's at RP32 DLL and others afterwards. And if it states it's a known DLL, yeah, then it's just one of the known DLLs. But if you have an exclamation mark, for example, here, like this, then it states that this DLL is not found in the same directory in which the original application is. So this is more or less saying like secure 32 DLL is not in the same directory and it's missing, but it's loaded. And this is also checking if these DLLs are vulnerable, so or if the application is vulnerable, so that it loads these DLLs if you put your own DLL in the same directory. And in this case it tells us that OneDrive.exe is vulnerable for 1, 2, 3, 4, 5 different DLLs, which are all default Windows DLLs and which are typically found under C Windows System 32 and then the corresponding DLL name. So these are all Windows DLLs which are typically found there. But the thing is that OneDrive.exe, if you put your own DLL in the same directory, so in this case it's lying here, not in the actual real path, but in a custom path, and if you put your own DLL, which is just named like one of these in the directory, in combination with, if you export the same functions which are needed by the application, then yeah, you can basically execute your own payload. And in this case, I'm going to go the simple way. So I'm not going to put every single API, every single function which is needed into the code, but instead we're going to use one tool which more or less automates the whole process of generating a sideloading DLL. And yeah, so basically it's more or less, I'm going to show the example in Nim. Those who take a look at what I'm tweeting and what I'm doing in the moment or in the recent months will have seen that I'm mostly or nearly everywhere used Nim in the recent months. It's just because I really like the syntax, I really like to program with this language, and yeah, it has the benefits of C or C++ because it compiles to C or C++ depending on what you choose, and but it's much easier, at least for me, to write in this language, so I'm using that one. If we want to compile or first of all, I'm going to explain something about this. So this is very simple. It's just importing vnim especially or the most used parts of Vim. So this is more or less like when you import Windows.h in C or C++. Vim has more or less embedded all typical Windows APIs, all typical types like dword, LP void and stuff like this, DLL process attach, everything is defined in there. So if we import Vim or Vim-lean, then we can just use most of the Windows API stuff because it's all embedded in this Nim API. OSProc is just to, in this case, use this specific function here, which is used in Nim to execute some code or an OS command. And in this case we are executing cmd-exe/c calc-exe. Or maybe I'm not going to choose calc-exe in this case. So, but MS Paint, just because it's something different to calc then. Yeah, and if we compile a Nim DLL, then we always have to specify this function. This is just like it is, so you always need this one line in if you want to compile a DLL in Nim, because Nim will never expose DLL main by default, like for example C or C++ programs, but it will always expose this Nim main function. So this is the entry point by default in Nim applications. And we're going to also expose DLL main by ourselves. So we're going with this flag, we can say that we are exposing this function. And DLL main is needed in our case because the application which I will show you later on to clone an original DLL needs this function to be exposed. So if you're not using DLL main in a Nim program and if you want to do sideloading, it will not work. You definitely need to expose DLL main. Yeah, and then depending on how the DLL is loaded by our vulnerable application, something is done. We could also just say regardless of how the DLL is loaded, Nim main is executed. So Nim main is basically just our main entry point, and if we define any code afterwards, that will be executed when Nim main is loaded. But in our case we're going to say just do it when the forward reason for attaching the DLL is DLL process attached. If you choose, for example, all of them, then it might happen that your payload is executed once, twice, 3 times, 4 times, or even more often, because it will maybe try all of them. So we're going to use this, and compiling it is pretty much straightforward. You just need 2 more flags in comparison to other default Nim applications. So if you want to compile any program in Nim, you would typically just use Nim C and then your code, and then it would compile the Nim code to C and will build an executable code out of the C code. And if you in addition add these flags, app is equal to lib and -- no main, then you can create your own DLL. So we're going to do that with our code. So, and now just to take a look on how or which functions are basically exposed by our DLL, which we just compiled. We're going to take a look at this DLL with DLL Explorer. This is one tool from Nearsoft, I think. And if we and this can just show us which functions are exposed and where they are exposed. So in this case we see that DLL main is exposed and that Nim main is exposed. And so this is not enough for sideloading. If only these functions are exposed, in many cases it will not work. In some cases it might work if your application is just calling DLL main, but for all those Windows APIs, for example, they will never call DLL main, but they will always try to call a specific function out of these DLLs. So just to demonstrate that this is not working, we can put this Sideload DLL into our OneDrive folder. We could rename it to, for example, version.dll, because this is vulnerable and loads version.dll if it's in the same directory. And if we do that, we can see that we just get an error, because it's going to load version.dll, but it wants to load the function get file version info w, and this function is not exposed in our DLL. So this doesn't work, because we need to also expose this specific function so that it's working. If we would now add this single function and recompile and put the directory in, put the DLL in the same directory, then it would tell us that it needs a second function and a third function and a fourth function. And this is a not a really good, not a really nice process, and it makes no fun to use it like this. So typically, if I have any custom DLL or any custom vulnerable sideloadable vulnerable application, then I'm not going to go this way to just always add all these functions, but instead we can use, for example, PEStudio. I hope it was PEStudio. I think I did not prepare that much for this stream, but I think it was PEStudio which I was using always, because this also tells us there are also other ways. I think there's also Visual Studio DumpBin or something like this can also show you which functions are loaded. I think I also used this. Was it DumpBin? Studio console show imported, read imported functions. I think it was DumpBin or something like this. We will also see if DumpBin /symbols. Yeah, this is it, I think. DumpBin /imports most likely. But just going to check if this this is still loading PEStudio. In addition, I'm going to open up a Visual Studio command prompt. DLL Sideloading, Sideloadable. So OneDrive. So DumpBin imports OneDrive. Is it like, perfect, yeah, this is what I was searching for. So you can basically see which specific functions are imported for each DLL, if you use that. So you don't need to expose all functions of these DLLs, but you only need to expose the functions which are specific to our vulnerable application. So for user-env DLL, for example, we would only need to provide these two functions. And if these two functions are available, then sideloading should work. So for version DLL, for example, we would need to provide like 3 different functions. Those 3. And this is an easy way to look it up. And if you want to do it manually, and if you don't want to automate the whole process, maybe I'm also going to do that later on in the stream. It depends on how long everything will take. Maybe I'm also going to show this. But if you want to just see which functions especially are needed from an application, you can do this with DumpBin. It can only, just to be sure, because maybe it was too fast, it can only be used out of a Visual Studio command prompt. So you cannot execute this from a default CMD. So in this case, let's check if this is also exposing the functions which are used. Yeah. So this is functions. Is it the functions which are loaded? Yes, it's the functions which are loaded, I think so. Or am I wrong? User-env 2? Was it 2 functions from user-env? And 3 functions from version.dll, yeah, so you can also use PEStudio to do that. You can also use that because it's also showing all functions which are imported with the corresponding DLLs. Okay, this has background information. So we compiled our DLL, and in the moment it's just exporting DLL main and Nim main. If we want it to also export all the functions from one of our vulnerable DLLs, we can use NetClone, which is just embedded in this repository here, in this coupling repository, and this can be used to do dynamic export forwarding. I'm going to share the link in the chat. I think, was I already using other I can also show you at least one example on how to one DLL template for Nim. So if you want to do that in Nim, you don't need to do that in Nim, obviously. Of course, you can also do that in any other language. And also, I'm also going to share again the one tweet from myself, which was just about how to use Siofra to scan a whole directory. Okay, so this repository has one Windows version. It's written in C#, NetClone to do the cloning part, and there's PyClone, which is a Python script, so you can also use PyClone from a Linux system. You don't necessarily need to use NetClone, but I'm going to use NetClone because we are on a Windows system in the moment. And the syntax to do that is like this. So we're going to use NetClone, and our target DLL is the Sideload DLL. Then we need to pass the reference, and the reference is the DLL from which we want to clone all the exports. So in this case we're going to choose version.dll, and there is reference half. From my current understanding, NetClone is also forwarding the function calls from version.dll to the original one, and this can also be seen in if you're parsing the we can just parse the DLL again with PEStudio, for example. Then we can see that it's somehow forwarded, but it's not always working. I faced situations and binaries where the forwarding did not work, so the binary always crashed or it just hung and nothing happened. So yeah, don't put too much trust into the forwarding. Our output file will be DLL Sideloading Sideloadable OneDrive version DLL. So the DLL which should export all the functions from version.dll will be put into this directory, and it seems like it was put here. So this is our old DLL, Sideload DLL, and in the directory Sideloadable we now have the version.dll, and we're going to also take a look at the exposed functions again. I think it's easier to do that with DumpBin. DumpBin/exports version.dll. Okay. Strange, okay. It cannot pass that, but PEStudio can. So I don't want to troubleshoot too much in this session. No problem at all. Sharing is very important in our community from my point of view. Without people sharing stuff, we would not get forward. So this is our newly created DLL. We're going to check the imports now, just to be sure that the correct ones are exposed now. So, and if we take a look at functions now, no, exports, we can see that it exports now 17 different functions, and these 17 different functions are all forwarded to the location of the real version DLL. So this is more or less the forwarding part. So now they definitely exist, and they are in this case forwarded, as you can also see here. This is just the imports, so this is not what you should take a look on. The exports is the interesting part. What you can also see is that Nim main and DLL main are not exposed anymore. The tool is more or less removing the old functions and replacing them with new ones. I think one maybe for if some blue team or whatever is taking a look at this, there is one new section. So if someone used coupling for DLL cloning, I think there is one new section which is generated. It's rdata2, and in this new section all the exports are put in. So if you ever see any DLL and there's an adata2 section, most likely this is somehow sideloading generated with NetClone. But this is of course changeable in the NetClone code as well as this IOC. Okay, so our functions are exposed. So in the very end, if we execute OneDrive now, what should happen? DLL main is all DLL main entries are forwarded to the exposed functions. So DLL main is called over DLL main, Nim main is called, and then paint should be started. Let's check if this happens. Ta-da! Paint is started. So we could also now take a look at how this all looks in, for example, Process Hacker, because that's the important part. So indeed, as you can see, OneDrive.exe is started. OneDrive.exe is signed by Microsoft and is the legit executable. And OneDrive.exe started CMD.exe, and CMD.exe started, CMD.exe always has console host exe in the backend, but CMD.exe started MS Paint. So MS Paint is running under a trusted signed application, and this is one thing which evades many security solutions in the moment still. If you use OneDrive, however, and that's what I said in the beginning, it is likely that this will still get detected by some vendors, because it's a known executable on the one hand side, and on the other hand side it's a default Windows function. One more thing to mention, as you could just see, OneDrive is only executed when I closed MS Paint. So the whole process will hang if whatever you do with your payload is not properly exiting. So if CMD.exe is not properly exiting, or if MS Paint is not properly exited, then the real OneDrive.exe will never get started. So it really depends on how you execute your payload here, if it works or not. Okay, so this works, as you saw. And what is better than using an vulnerable binary which is importing default Windows APIs? One thing is less detectable than a vulnerable function, a vulnerable application which loads Windows APIs, like those which are placed in system 32 is, for example, any other custom ones. So if you have any third-party binary which loads its own DLLs and not Microsoft DLLs, then it's even less likely that this will get detected if you're using the same technique, because the AV or EDR vendors could, for example, take a look at your DLL and check if the DLL is also signed by Microsoft and if it's the legit Microsoft DLL. But for third-party vendors, that it's at least not that easy as it is for the Microsoft default binaries. Or they could just check, is the file really in the system32 directory, and if it's not there, it's potentially a sideloading vulnerability. So, but if it's any other DLL from any vendor, it's much harder to check for those EDR AV vendors, because they can just not have all applications in the world on their radar, and they cannot know which DLLs are loaded by which application and what is normal, what is not normal. It's just too many possibilities. So we're again going to check another binary. In this case, we're going to check Chrome, so the Chrome browser. And as you can see, the Chrome browser seems to load Chrome_elf DLL. This, in addition, loads kernel32 DLL and one more Microsoft DLL. Version DLL is loaded, which is also a Microsoft DLL. And this one is also loaded. I think this is also a known Windows DLL, but this Chrome_elf DLL is specific to Chrome. So if we take a look at the location from Chrome, I don't want to start it actually. Just want to take a look in the directory. Oh, come on. C program files Google Chrome. It's C program files Google Chrome application. So there's Chrome DLL, and by default this loads Chrome_elf DLL. Just check where it is. It is here. By default it's laying not in the same directory, but one directory afterwards. So it's loaded in, by default it's loaded from here, but this application is still, and that's what you can see in the output. Oh, you cannot see it. Interesting. Ah, I know why you cannot see it. You cannot see it because I already placed one Chrome_elf DLL, which is from myself, into the directory, and therefore Siofra said it's not vulnerable, because it found the existing DLL and then it says it's not vulnerable. So if we delete this DLL and if we scan it again, it will tell us that Chrome_elf DLL is vulnerable. So sometimes it just makes sense to copy, if you want to check for the vulnerability, to copy only the executables into a separate directory and scan them in the separate directory, because then they will not have all the DLLs which they typically have in their directory there. Yeah, there are some side effects, like you can for example not use any DLL for persistence. So which was published is, for example, the Teams version DLL combination, and that was used for persistence, so pushing to persistence more or less by just dropping the version DLL into the Teams folder. This cannot be done for all, but it was also not my main use case to reach persistence with sideloading. but you can use sideloading as a very good, on the one hand side, initial access vector for phishing, but you can also use it for lateral movement, for example. You could copy the Chrome.exe to another system and the DLL in the same directory, and then you could execute Chrome. It's not as suspicious as executing any unsigned executable, and your payload will get executed. And this was the, for me, more interesting part than the persistence part, so I'm also not going to focus on this persistence thing here. You have to check this different, because you need to have write access. You don't want to replace existing DLLs and stuff like this. Yeah. But what I wanted to say is now it tells us that Chrome.elf DLL is vulnerable. Means it tries to load Chrome.elf DLL from the current directory, and we can exploit that by generating an DLL which exports 1, 2, 3, 4, these 4 functions, because these 4 functions are needed from the original Chrome DLL. And just as an easy effect to show you how the whole process could, for example, be automated, I'm going, because it's just in this information in the moment, I'm going to show you how to do that with my Packer. So you could say I want to, for example, load shellcode. I want to load shellcode which is called calc.bin, and you would like to expose all these functions which are mentioned, and the output has to be Chrome_elf.dll. Then my tool will I can take a look at the output later on. In this case we are not cloning the DLL, but we're instead exposing these specific functions. I think we can also do this manually later on. So I'm taking this shellcode from here. This shellcode will get encrypted. It will get embedded into Nim code. It will get decrypted on runtime, and we will compile a DLL which exposes these functions here. And this DLL will, if it's loaded, decrypt the shellcode and load it with syscalls. So it's also possible to execute. It's possible to do everything. It's possible to execute shellcode. Everything which you can do with code, you can also do in sideloading. Nearly everything. So we have this directory. We have the sideloadable folder. We have Chrome, and we put the Chrome.elf DLL in this directory. So as you can see, this should be the one which I just put here. And if we now execute Chrome, voila, our shellcode is executed and popped up. As we also can see, Defender is on, Cloud Protection is on. There was no detection at all for this shellcode, and this was, by the way, MSF Venom shellcode. Yes, yeah, we can try to do this manually, but I don't have the code for generating or exporting the functions in my mind. So I'm going to take a look on how to do that myself. One moment. It's pretty easy. It's as easy as doing this. So if we want to expose another function, we can use just this. It's just like the same which we did with DLL main. We're just using the same input parameters. We're using the same output, and we also just call nim main when this function is called. For some vulnerable binaries, this here will not work, because at sometimes you will need to really have or use the specific parameters which are needed for the function. So if version.dll is called and one specific function, you need to take a look at which function or which parameters are typically passed to this, which types do they have, and then you need to create your own the same parameters with the same type here. Otherwise it will not work. If we take a look at OneDrive, we're going to take a look at Chrome, and we want to see the exports from Chrome. So it was Chrome, was it these ones? Is that in the text file? Signal initialize crashing report. No, it's different. Is it different because the DLL is in the same directory? I'm not sure, or I have to check for imports. It was imports, not exports. Okay, this looks better. So our vulnerable DLL was the Chrome_elf DLL. And this is, and these functions are imported. Get install details payload. So this is the first one. If we want to expose another one, we can just copy the code and use it again. So our second function will be this one here. The third one is signal Chrome_elf. And the last one is signal initialize crash reporting. So by doing that in our code, we will again start MS Paint. Just let it stay like that. So what did we just do? Do I have the command still? Yes. This was our initial command to compile the Nim code. We will again compile that. Sideload.nim. We can again check. Maybe this will work, because now it's not manipulated with coupling, but it's we did that manually here. So we manually exported the functions. So there is DLL main, there is get install details payload, there is browser process, there is still nim main, there is signal Chrome_elf, and this last function, and they are all exported just as we wanted. Then we're going to copy Sideload DLL to cstream sideloading sideloadable Chrome, and we will call this one Chrome_elf.dll. I think this was the correct name. Not 100% sure, but this is our compiled DLL, which exports the correct functions. And if we now execute Chrome, ta-da, CMD is spawned, and CMD spawns MS Paint. We can again check. No, this is not what I was searching for. In Process Hacker, how this looks like. And as we can see, Chrome.exe did spawn CMD.exe, and CMD.exe spawned MS Paint. And if we take a look at the properties, we can see that this DLL is loaded, which is our malicious one. And what did I initially wanted to check here? Can I check the signature in Process Explorer? I don't know for sure. But we can do that here again. Ticketer signature, details. So this was also only valid till September 2022, but I don't want to leave it like that. So I'm going to replace this Chrome version with the newest one so that you can see that it should also work with the newest one. Okay, our payload is executed twice, and a third time, and a fourth time. So in this case, if we did it manually, Chrome tries to load this DLL multiple times. Maybe this was for each function. For each function which we exported, nim main was called one time. So it was once called for this one, it was called for this one afterwards, then for this one, and then for this. And this leads to the fact that our payload is executed 1, 2, 3, 4, 5 times in a row. If you want to avoid that, you could just get rid of calling nim main again in every function. So this would lead to our payload only getting executed once. I also had some side effects in my testings that my payload was executed like 20 or 25 times, and I did that with a C2 agent, and then I had 20 or 25 incoming connections for one single application. Yeah, so you have to test properly before you deliver that payload to make sure that it's not executed like 20 times in a row. So we're going to check where Chrome is. I did that already. It was C program files, Google Chrome application. So this is a new one. Should be October. Yeah. No. We already have November. This is not the actual one. I did not run my VM for a longer time. I don't know how long it takes to update itself. Anyway, it's newer than the one which we just used. So I'm going to put this into our directory. Stream, DLL Sideloading, Sideloadable, Chrome. We replaced the one which we had here. So we have the new one. Executing that. Side-by-side configuration is not correct. This is one fact which I did not tell you yet. This manifest file needs to be in the same directory for Chrome to start. If the manifest file is not in the same directory, it will always complain. So in this case, it should be one of these two manifest files. And again, it works, even with a newer version. But this will definitely also work with the newest version. I don't think anyone talked about Chrome sideloading so far. Yeah, if you do that for a whole directory, which I mentioned in the very beginning, and that's what I would recommend to you, you should definitely search for your own vulnerable applications and use them instead of using ones which were published and which are already known. So it's much better to check binaries on your own, find your own custom DLL sideloading vulnerability, build your custom DLL for that one, and yeah, you should be fine in many cases in terms of not getting detected by AV or EDRs. One funny side effect, at work we just tested uploading an unsigned raw Rubios version from just from GitHub to VirusTotal, and it had like 57 detections out of something with 70. And we signed that Rubios version with a code signing certificate and re-uploaded it just to see what happens with it. And just because this Rubios version had a certificate, a valid certificate, the detections dropped to like 25. So half of all vendors just did not analyze this file anymore and did not check for signatures and did not check for any malicious content, because they saw that this is signed by a legitimate certificate. So this is more or less the effect which you get. One effect, because on the one hand side the application may not get analyzed anymore by half of the vendors, but on the other hand side, in this case it's the DLL which executes the payload. If the executable is analyzed, they will still see nothing in the very first place, because it's the legitimate executable from the vendor. Yeah, this is the big benefit. Okay. Yeah, this was more or less everything which I just wanted to show today. So I finished much earlier than in nearly all other streams, but I think that's also already it. There's not much more to show. Does any one of those guys which are currently here have questions or something like this? So I did not plan to talk about what is the best way to copy this malicious DLL. So you mean in terms of persistence? I mean, in general, this is where all the other important AV evasion things apply. You should never still use, for example, plain shellcode here. So you cannot, if you embed a plain MSF Venom byte array here with shellcode, for example, and if you use that for sideloading, it will definitely still get caught, because your DLL will get caught by signature. So you have to always still apply more or less the things which I mentioned in all other videos I did before for your DLL, to make sure that your payload is not called, which in the very end means if you want to execute code via this technique, I would always recommend you to on the one hand side encrypt or somehow hide, obfuscate your payload. Make sure to use syscalls for shellcode execution. So if you don't do that, your shellcode will get caught by hooking and by userland hooks. If you want to execute any .NET or scripting language, JS or VBA or whatever, patch AMSI. If you're loading any .NET code, or I mean in general ETV is used more and more, make sure to patch ETW, not ETV, I'm always getting that wrong. Yeah, this is more or less the very minimum you should still do and apply in your DLL payload to make sure that the payload works properly. I can show one example, one more example. So if you did all this stuff, it should not be a problem to just copy the file to a remote system. It should also not be a problem to copy the DLL out of whatever to a directory, because it should not get flagged, because the payload is encrypted, the payload is executed in a stealth way, and this should pretty much be fine. So as long as your DLL is not detected by a signature on disk, and as long as you properly, with the corresponding techniques which I just mentioned, execute your shellcode or payload, you should be on a safe side. What did I also wanted to say? For example, one thing which was mentioned for initial access. So there was, I think it was Palo Alto. A BRC4 detection block, ISO files were used, Sideloading, maybe I find it like this, yeah, this is it. So in this blog post they describe one technique which is from my point of view very nice, and one of the ways to go in the moment to deliver payloads. So you could, for example, use an ISO file. ISO files are good because they can still be used as an attachment in emails. They are currently not really good scanned by vendors, so they cannot really check what is in it, so they are not good at it yet, not very good. And if you do it like it's described in this blog post here, then this is one of the best techniques from my point of view in the moment, because they were using, this APT group was using a link file, and this link file was embedded in the ISO image, and if you execute the ISO, then a new disk will be mounted to your system, and then there is a link file, and this link file executes hidden files which were also embedded in the ISO image. So there was one OneDrive.exe, there was one file which was just called OneDrive.update, and there was a version DLL and a version DLL. And this link did execute the hidden OneDrive updater.exe. OneDrive updater is vulnerable to sideloading, and OneDrive updater did load the version DLL. This version DLL did load and decrypt this file here, which was the payload, and executed the payload in memory. And afterwards it did load version DLL, which was the original version DLL, so that this OneDrive updater.exe was executed properly afterwards, and it did not crash. And this is really a good stealth approach, because it's really hard to detect. And if you upload version DLL to any sandbox or whatever, it will not get detected because the payload is in a separate file. If you update OneDrive updater, it's not detected because it's legitimate and signed. So this is a pretty good approach, but you should read this blog post to get an overview about how this technique is working. I could do it with TeamViewer, of course, but I did not want to spend too much time now here in this stream, because all my other streams were like 3 hours, but I did not want to spend 3 hours today, to be honest. So I will not do that now in here. But from the information which I gave you in this stream so far, you should be able to build your own DLL to find out which functions are needed to build your own payload and to do that. One more thing which I will show you, which I'm going to show you, is a more proper payload. I'm just going to kill OneDrive for the moment. And we're going to create a new payload again. So if you do everything properly with the evasion stuff, you could, for example, this is for Chrome, I'm not going to use Chrome. Also execute any C2 stager. So in this case, meta.bin is a Meterpreter stager. And I'm going to encrypt this Meterpreter stager. I'm going to build an DLL which uses this calls to load it. It will patch AMSI, it will patch ETW. And this can be put into the corresponding directory. Stream DLL Sideloading, Sideloadable, Chrome. Yes, replace it. And now we have a new payload here, Chrome.exe DLL. Just going to check whether Kali is still running. Okay, there also is an handler for Meterpreter active. So, and if we now, and just to demonstrate it, I'm going to put this on the desktop. So the copy part, which I just mentioned, should not be a problem if your DLL is not detected, because I just copied Chrome.exe and the DLL to desktop, pretty much normal. Defender is enabled, cloud protection is enabled, and nothing is complaining. And then I'm going to execute Chrome.exe. Oh! I did not expect this to happen. Let's see what it flags. Okay, this is not my payload. This is another one. Not a problem. And what did it also detect? Nim. The Nim zip. Okay, both false positives. At least not relevant for this. And as you can see, our DLL was still loaded. And demonstration effect. Demonstration effect. Timed out. Okay, I'm going to choose another technique, because I think this is what I also mentioned at some point. You should always properly test your payloads before you deliver them. It may be the case that local injection makes a problem here, but injecting the payload into a remote process should be better then. If I tell my packer to do remote inject, for example, and I want to inject into, do I want to spawn a new process, or do I want to inject into an existing process? Good question. Remote injection could again also get detail. I'm first going to try something else. local create thread. I'm going to create a thread as a payload instead of just pointing to the shellcode. I think the pointing to the shellcode was a problem here. Let's see if this will not lead to a crash or a timeout. Yeah, this works. So if we create a thread instead of directly pointing to the shellcode, so I may have changed the exit method in the payload. If I had set it to exit method thread, for example, it should have also worked in the first case. Now it does work for, yeah, this was the issue. I'm now using a custom thread, and this custom thread will not die, but it will stay alive, and therefore our payload is executed. We can again take a look at the process itself. So Chrome should now still be running. As you can see, there is no other process spawned. This has our Chrome 11 loaded, and if we take a look at the memory, maybe we will see our RWX region, which is the payload, and Meterpreter in this case, because it should be in the same process. RWX, yeah, this should be it, most likely, because Meterpreter typically loads like standard lib, which is one DLL, which is newly allocated and executed. It loads 1, 2, 3 more other DLLs. So I would assume these things here are Meterpreter directly loaded in Chrome. MZ, this is definitely in DLL. This is also in DLL, so this is Meterpreter. MZ headers just means that these are the reflective DLLs which are loaded by Meterpreter. And Defender did not complain. Okay. It's not started as admin, but yeah. Screenshot. So we can also use modules here, looks like, without getting detected. We can share the screen, get the screen. Defender's not complaining. It's a good technique. Okay. Any other questions? So this packer, if anyone asks, this is sponsorware. You will only get that if you sponsor me, because it's private and it will stay private. If I publish that, it will, of course, there will be signatures for the payloads and it will instantly get detected. It just makes no sense to publish it. It makes no sense to publish any tool if you don't want it to get detected. And what it can also do, there's a clone function. Did I show the clone function for version.dll? I think I did. So this just, you have to just specify the DLL to clone, and then it will generate a DLL which has especially the functions exposed from the corresponding DLL. And this is done by using NetClone in the very end, which I showed you in the stream. Did you do that on Patreon or on GitHub? Because on Patreon you typically directly get access to the posts, and on GitHub I'm manually checking that and inviting the people afterwards to my GitHub organization. Just in the best case, just hit me up on Twitter and tell me your GitHub username, and then I can check that. It's possible that I somehow missed the email, and then if you just write me, then I can invite you. I'm also just a human, not perfect. Okay, I'm going to quit the stream now, and I will, as always, upload the video later on the YouTube channel, so that you can also take a look later on at the commands, tools, whatever. And have a nice day, evening, weekend, and see you somewhere in the future. Or maybe we'll write in the future, who knows. Goodbye.